All right, so any questions so far?
Understand the idea of the one that you showed about the video, right? Just the white image without any pixel values, a grayscale image, right? So the purpose of what's the purpose of having the dots? The dots is just pixel values showing a patch from a pixel from an image. The walking
Those are the joint angles.
triangles. Okay.
So you have a skeleton, human skeleton, right? So
Mm-hmm.
joint angles are like the important, the salient parts of your skeleton,
Yep.
where two different like part of a skeleton meets. For example, like for arm, you might have a joint angle. For
Mm-hmm.
shoulder, you might have one. Similarly, like for elbow, you might have one. So you have 25 different joint angles. And again, it depends like how detailed you want it to be. It could be just 10 joint angles or 15 or 25.
So then,
Okay. All right, good. So if no other question, let's move forward. I think someone was saying something. Yeah, go ahead. There's a question from Anthony. Are the kernels used in a CNN considered features? That's a good question. And so kernels are, there are two aspects to it. And okay, so first of all, kernels are not features. Okay? Kernels are something which are learned when you train your model, and they help you in extracting features. Features will be something when you apply those kernels on your input image. Those extracted activations will be features. Okay, so that's one level of understanding. Now, if you go a little deeper, then if you know from like filtering, we have been studying filtering a lot, right? Kernel is, when you're applying kernel, you're filtering, you're kind of doing pattern matching. So what's happening is you will have high activations when your kernel will match with your input image. So if you think from that point of view, then kernels are kind of representing those features which you're interested in, right? So it has like some, you can say like some symbolic connection. Okay, but no, so kernels are not features. Features are like what you will extract, but there is some correlation between those two. Okay, good. So was there any other question? I think someone was speaking. If no, then we can move forward. So that was the first key point detection algorithm I wanted to discuss. And I think we are almost at the end of the lecture. Any questions you have? Okay, question from Shashank. Has detector something novel or it's old like Canny Edge detector? What do you mean novel? It is novel, right? Or you mean new? Yeah, it's not that old. I think it's 98 or around that year, right? Let me check for you. Yeah, 88. Not that new, but not that old. Because edge detection was like a more primitive problem, and key point is like, you can say, more advanced problem, right? More difficult than edges. So roughly after maybe 20 years of that. Yeah, I mean, I understand like why you're asking. It's old algorithm, but again, there are a lot of interesting things here, right? And even if you're developing your deep learning algorithm, like some of these insights, I think is very useful for solving those problems, right? Because this is kind of like looking at at a very granular level, right? How we can solve it. All right. So any other question? I think we can end it here today. We don't have a lot of time to move to the next segment. And if you have any questions, I'm still here. But yeah, best of luck for like a preparation for the midterm. Next Thursday, I think you should all know we'll have midterm. We'll start sharply at 4:30. So join slightly like before that, maybe 4:25, because we will release like at 4:30 and you will have exactly 60 minutes to solve it. There will be like strictly no extension to it. Okay. Question from Robinson, repeat what until what material the exam? Yeah, it's like the last lecture, right? Until it was tutorial on PyTorch, right? Yeah, it was tutorial on PyTorch. So whatever we covered like until last Friday, last Thursday, that will be your course for midterm. We won't cover this topic. Yes, PyTorch. Yeah, thank you, Akashdeep. So until PyTorch tutorial will cover in the midterm. Yes, you will need a webcam. Yeah, okay, that's right. Lecture 8 plus PyTorch tutorial. So I thought PyTorch tutorial was lecture 8. No, let me check. So we are on lecture 9, which is features. Yeah, lecture 8 was PyTorch tutorial. So until lecture 8. That's right, okay. Okay, question from Taylor. What do you expect grades to be like? Do tests get curved? Yeah, I mean, if the grades are low, we'll curve them, but it's usually not done in this course. Usually, I think students get good grades in this course because the exams are not that hard. If you're just following the lectures and following the slides, I think you will be able to do well. Okay, Taylor, I'm not sure if that answered your question, or if you want more clarification, please let me know. Question from Prithvi, how many questions? Yeah, I think Sunit Shashank answered that. We'll have 20 questions in total. Okay, question from K. According to the YouTube video post, lecture 8, training neural networks. Then PyTorch tutorial can. Oh, okay. I think that's a mistake. The Binay might have made that mistake because training neural networks was lecture 7. Yeah, let me put an announcement to that. I think that's a mistake on today's part. We will fix that. So it's lecture 8, PyTorch tutorial. Okay. Thank you for letting us know that. I will make an announcement for that. Okay, question from Anthony. Could you release answer for Yahoo? Yeah, I think we should release it later today, 4 and 5. I'm not sure why they were not released earlier, but yeah, we will do that. I think Ami has the same question. Yeah, we will release like all of those. All right, so I think if there is no other question, we can end it here. Thank you all, and good luck for the midterm.